antibody-mediated vaccines. And this illustrates a complete shift in terms of the vaccine paradigm. Most of the time we think about a vaccine that protects completely against infection. That's what's shown in the second panel here. You would have a virus entering the body and absolutely no virus ever occurs because you get clearance with the antibody. A second type of vaccine would either give a very low amount of virus or give you a lower level of virus than complete protection. And that's actually what was proposed in 2002 in Barcelona, and that is to basically lower the viral load with a vaccine. This just recalls what happens in HIV infection. You get an acute infection which drops your T cell count, they come back up, and then they slide down towards AIDS. CD8 T cells are preserved. The viral load varies, generally is low in chronic HIV infection, but eventually at the end when AIDS occurs and there's complete immune suppression comes up. So the idea would be that we would be trying to lower the viral load to prolong life and limit the impact. There's actually good data showing that people who have lower viral loads live much longer. So people who have, as shown on this slide, less than a certain number of copies per cc are more likely to survive, 89% surviving if they have less than 5,000 copies, whereas people who have 36,000 copies in their blood, 62% of those people are dead within the next 5 years. So a vaccine that can lower viral load is one of the targets that we're trying to achieve. This was actually described at the Barcelona conference in 2002, and the idea was that we would be trying to make a T-cell mediated vaccine that would contain infection. There's good data that this would actually protect against transmission. Remember, that's one of the goals of the virus, the vaccine that we'd like to develop. This is a study that was done in Rakai where they looked at discordant couples, one person with HIV, the other person either a spouse or a partner without HIV, and they looked at the virus load in the person who had the HIV infection. They were more likely to transmit to their partner if their viral load is high, and less likely to transmit if their viral load is low. And people have actually modeled, mathematical modelers have projected that a partially effective vaccine might actually be able to reduce HIV transmission in a population and eradicate HIV, get the HIV transmission below that magic number that allows it to continue to propagate in a population. So then what became the focus? Well, the focus became T-cell mediated vaccines. Here are some of the approaches that people have looked at, and I'm really just going to talk briefly about live recombinant vectors. These are virus packages that contain the genes from HIV infection, and the particular virus package that was chosen by Merck is the adenovirus. A standard cold virus. Most of us have actually been infected with adenovirus. They use this as the package to deliver the genes from HIV to create an immune response that was T-cell mediated. They studied this vaccine all over the world. The studies actually started about 3 or 4 years ago. A large phase 3 trial, 2B, actually a 2B trial, which is a particular type of clinical trial. They enrolled about 6,000 people in different regions of the world. And in parallel, there was a study in South Africa with the same particular vaccine, but being performed by the HVTN, the HIV Vaccine Trial Network. Most of these studies are actually paid for by the US government, even though Merck made the vaccine. Now, a note about this particular vaccine. This vaccine is a clade B vaccine. It is not developed for other regions of the world. It does not contain epitopes, those little messages to the immune system that represent the flavors of HIV that are being transmitted in Africa, and yet it's being studied in Africa. From what I've just told you, you would think that even generating an immune response against a clade B virus, it would be unlikely to protect against the clade Cs that are found in South Africa, because the epitopes are not the same. Merck waved its hands, did some some fancy T-cell assays with lots of overlapping peptides and came up with an answer that seemed to suggest that there might be enough cross-reactivity with the whole genes that they were expressing to perhaps protect, and they argued that this might be a good idea to at least test this vaccine and see if we could get protection against different strains of HIV. Now, I also want to note that most of the preclinical studies are done in monkeys, non-human primates, that are infected with not HIV, but a strain of monkey virus, SIV. And whenever they're testing vaccines in these monkeys, they usually immunize with the vanilla flavor, and then they challenge with the vanilla flavor, and when they get protection, they go, oh, we can protect monkeys from HIV infection or SIV infection, therefore we should go ahead and do studies in humans. There are very few studies in monkeys that have been performed with the type of variation that exists in the real world. So again, the scientists have been concerned, and they have said, you're vaccinating with clade B, that makes sense, you're a Merck, you're going to be making a vaccine for the United States of America where you can sell it for lots of money. You're really not that interested about making a vaccine for other areas of the world. We understand that. You argue that it will provide protection, but the scientists were very concerned. They were concerned there wasn't going to be enough breadth of immune response and that there wasn't going to be protection in this trial. So the news was not surprising to many of us in September, and then in November when the data finally came out, that there was absolutely no protection. The two trials that I talked to you about, the Merck study that was in North and South America, and then the South African study, were both discontinued. But even worse, and I'll show you what actually happened, and that is, as shown here, people who got the vaccine were more likely to come down with HIV. This is about the worst possible outcome for a vaccine trial. Imagine you're a vaccinologist, you're me, I'm standing up here, and I'm just told you that people who got a vaccine and not placebo were more likely to get HIV. This is the worst possible outcome. The numbers were small, so here you can actually see in the vaccine arm, 49 people got infected out of about 600 when they broke the code here. And in the placebo arm, 33 got infected. And it turned out what was very strange about this particular study was that the people who had high pre-existing antibody titers to the adenovirus, the package that they had put the HIV genes in, were more likely to get HIV when they were exposed to it. So 21 people out of the high adenovirus titer group were infected, whereas only 9 of the placebo group. So there was something about the reaction to the vector that made people more susceptible to getting HIV if they got the vaccine. So they stopped the study. They actually do this as a standard in all clinical trials. They have what's called a data safety monitoring board that looks at the data to determine to see if there's any problem with the vaccine as the trial is going on. They stopped the studies and they started trying to think about what was actually going on. And I'm only going to present to you a summary slide because there's so much data coming out about this. I just want to really hit the time points. And basically, what they looked at was how the study was designed. They looked at both groups, the placebo group and the vaccine group. They saw no behavioral differences. That was almost the first question that they wanted to ask. Were the people in the vaccine group taking more risks and more likely to be HIV infected than the